Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. I don't know why, but my I was stumbling over those words. Um, Today's very easy puzzle is called Bouquet and Candies by Katie Splendor. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have W arrows, where the first n digits in the direction that the pink arrow points, where the arrowhead is the first digit, and the digit in the on the shaft is n, add up to the small number in the arrowhead cell. Different arrows can share the same shaft digit n, but point in different directions to different sums. So the first n digits in, so it's basically like an x sum, except that the x is not along the path that the arrow is. It's basically on the shaft. So this is n for all of these arrows. So if this were, say, 4, that means you have to look in each direction for 4 cells. And these 4 cells, for example, would have to add up to 20. So you could have something like, I don't know, 3, 7, 9, 1. And this would be valid because the first 4 digits, which is the digit n, which is the digit on the shaft, add up to 20. 3, 7, 9, and 1 add up to 20. And that's what the number in the small arrowhead is. So this is an example of how these W arrows work. We also have ratio Kropke, where digits separated by a black dot have a ratio of 2 to 1. There is no negative constraint. So, for example, if this were a 4, this would have to be 2 or 8 to be maintained the 1 to 2 ratio between them. We have ambiguous XVs, where digits separated by a pink dot sum to either 5 or 10, and there is no negative constraint. And the negative constraint would mean that well, we don't have to explain that too much, but basically, it just means that we have information here. So, for example, say this was a 9, then this would have to be 1 to add up to 20. Oops. I have settings. I don't know. Where is this? Check pencil marks off. Conflict checker off. Mark solve digits off. Okay. Check unfinished. Apologies. I think I recently cleared out my cookies, so I don't know what settings I have here that is actually correct or not correct. Anyways, but for example, any digit that has a pink dot between them must either add up to 5 or 10. That's an example of how these ambiguous XV cells or dots work. We have German whispers, where neighboring digits along a green German whisper line differ in value by at least 5, and Dutch whispers, where neighboring digits along an orange Dutch whisper line differ in value by at least 4. And I call these Whisper 5 and Whisper 4 lines because a setter came up with this naming convention, and I thought it's very easily extendable. So I thought it makes a lot of sense to be calling it that. So know that when I say Whisper 5 or Whisper 4 lines, they're basically German Whisper and Dutch Whisper lines as examples. For example, actually, what do you call the Whisper 3 line? in this naming convention of German and Dutch. You can't, right? Or you just make up something, right? You just, I don't know. Or what about a whisper 6 line? What do you call that? Don't really know. But it's very simple to easily extend this from whisper 5, whisper 4 to whisper 3, whisper 6, right? So that's the reason why I call them that. Anyways, as an example, say this was a 7 here, this would have to be 1, 2, or 3, because the only digits which are 4 or more away from 7 are 1, 2, and 3. Similarly, if this were 3 here, this would have to be 8 or 9, because the only digits which are 5 or more away from 3 are 8 and 9. And that's how example of how these German whisper slash whisper 5 lines or Dutch whisper slash whisper 4 lines work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so because of these W arrows are very limiting, let's start with that. And we know that to add up to 20, it's going to have to be at least 3 digits, right? Because the most of 2 digits is 9 and 9. So therefore, you are guaranteed at least 3 digits to add up to 20. But to add up to 6, if you have this as 4, which means these 4 add up to 6, the problem is these 3 at minimum add up to 6, which is 1, 2, and 3. And therefore, this would be 1, 2, and 3 plus at least a 1, which means its value of 7. So this can never have a value and can never be 4 in that case, which means this has to be 3. So since this is 3 digits here add up to 20. 3 is also in a 1 to 2 ratio with 6 only. 3 adds up to 5 and 10 with 2 and 7 explicitly. So, we know that these 2 digits here must be at minimum 3. So this digit here must be a maximum of 3 itself. Well, the thing is, because we have a 2-7 pair in the box and a 3 in the box, this can't be 2 or 3, it has to be 1. Which means these 2 digits must add up to 5, which is 6 minus 1. So since these add up to 5, along a whisper 5 line, you'll always alternate between low digits and high digits, because what digits can be next to a low digits being 1 through 4, high digits being 6 through 9. Because what digits can be next to a low digit, which is 1 through 4? Well, 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can only be next to 9, all of which are high digits. And what digits can be next to a high digit? 6 can be next to 1, 7 can be next to 1 or 2, 8 can be next to 1 through 3, and 9 can be next to 1 through 4, all of which are low digits. And 5 can never be on a whisper 5 line, because if you subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. If you add 5 or more to 5, you get 10 or more, which is not a digit. So 5 can never be on a whisper 5 line. You'll always alternate between low and high digits on a whisper 5 line. And since this adds up to 5 at most, these have to be low here. Both of these. So therefore, this next to it on a whisper 5 line, it can only be high digits, which means these are low digits, which means these are high digits, which means this is low, this is high, and that's low. Okay. So these have to add up to 5, so they're 1 through 4. That means this must be a, well, we don't know. This, oh, we do know. This adds up to 5. So since this adds up to 5, if this added up to 5, these would be the same digit, which is not allowed in Sudoku. So therefore, this must add up to 10, which means this is a high digit. This could add up to low, or it could add up to, so it could add up to 5, or it could add up to 10 here. We're not sure. Anyways, so this adds up to 6, this adds up to 20, And the remaining digits in the central box have to be 4, 5, 8, 9. Okay. This cannot be, well, it could be 4 if this is 7 and 9. 5 works with 6, 9, or 7, 8. Oh, we know that this 7 cannot be next to a black crop key dot because if 5, 7, and 9 actually cannot be next to black crop key dots. Because if you have those digits, you get 2.5, 3.5, 4.5, which are not digits. If you double them, you get 10, 14, or 18, which are not digits. So therefore, this can't be 7, it's 2. This must be 7. 2 is only in a 1-2 ratio now with the remaining digits of 4. So this is 4, which means this adds up to 620 here. So these two must add up to 16. So they have to be both high, and they must be 7 and 9. This digit must then add up to 10 with these two digits here, because 7 and 9 are already greater than 5. So this is a low digit and is 1 or 3. This must be next to a 7 or 9 on a whisper 4 line. That means 7 can only be next to 1 through 3. 9 can only be next to 1 through 5. So and it can't be 1 or 4 here because of the 1 or 4 in the column. So this is 2, 3, and 5 as possibilities. Okay. This is 3 and 7. Okay, so 3 to the digits again next to a black crop key dot cannot be 5, 7, and 9 because of what we said earlier. And 3 and 6 is removed from this pair because of the 3 in the row. So the only digits remaining then are 1, 2, 4, and 8. Well, that eliminates 1, 2, 4, and 8 in the rest of the row. So the remaining digits in the rest of the row are 5, 6, and 9. Well, 5 can never be in any relationship with another digit to add up to 5 or 10, because 5 would require, to add up to 5, 5 would have to add up with 0, which is not a normal Sudoku digit. To add up to 10, they would have to be 5 and 5 adding up, which obviously you can't have, because we can't have duplicates in a row. So therefore, none of these are 5. So this is a 6, 9 pair, which eliminates 6, 9 in the rest of the row. This can't be 9 here. It's 5. No 5 here, no 5 here. To add up to 10, well, you can't add up to 5 with 6 or 9 because they're both greater than 5. So it must be with 1 and 4 to add up to 10. So this is a 1, 4 pair, which eliminates 1 and 4 in the rest of the box. Interesting. So if this is 4, if this is 1, 9 has to be here. If 4 is here, 9 has to be here because 4 can only be next to 9 on a whisper 5 line. So 9 in this box has to be one of these two cells. It's the same logic for here. If this is 1, that's 9 guaranteed here. If this is 4, 9 has to be next to it on the whisper 5 line. So therefore, one of these two is 9. So we are guaranteed a 9 in this left central box in rows 5 and 6. We are also guaranteed a 9 in this right central box in rows 5 and 6, which means we cannot have another 9 available in those rows. So this cannot be 9. This is 8, which forces this to be 9 here. So therefore, we know these two digits add up to 15 minus 8, which is 7. So that makes this 1 through 6. So we have 1, 2, 3, 4, and 3, 4, 5, 6 adding up to 7. And we have this is also adding up to 7. So this must be 1 through 6, and this must be 1 through 6. 5 cannot be here because it's next to a black crop key dot, so this cannot be 2 and 5 there, adding up to 7, which it does. 16 minus 9 is 7. This is a low digit, and it must be next to 3 other unique digits on a Whisper 5 line. So this cannot be 4, and we can't have 2 or 3 here because of 2 or 3 in the column. So this is 1, which eliminates 1 in the rest of the row. So this can't be 1, which means this can't be 6 here, and this can't be 4 here. 1 is next to 6, 7, 8, and 9. Obviously, this can't be 7, no 8 or 9 here. This digit is next to 2 unique digits on a Whisper 5 line, so it can't be 6. 6 is only next to 1 unique digit, 1. So this must be 7 here, which means this must be 2 here to be next to a 7 on a Whisper 5 line without it being 1. Therefore, this can't be 2 here. There's no 3 here. These add up to 7, so this must be 5 here. 2 and 5, so this is either with 3 or 8 here, adding up to 5 or 10. Okay. This can't be 6 because of 6 in the column. 3 and 4 here must be next to another digit here, which means this can't be 6 because 3 can only be next to 8 or 9, 4 can only be next to 9, so this is 8 or 9 too. Okay, 2 can only be next to 7 or 9. This 8 eliminates 8 here, so this must be 9 here, which makes this 6 and this 4 to add up to 10. So therefore, this is 4 and 9. This can't be 4. It's 1, which makes that 9. So this can't be 9. That's 7. 1 is a 1 to 2 ratio with 2 out of 2 are 8, and therefore this is 8 here. 1 eliminates 1 here, so this can't be 1. That means this can't be 6 here to add up to 7. 3 and 4 must be with 6 or 7 here. If this were 8 here, the problem is that would guarantee this is a 3 here, but that would eliminate all possibilities for this cell here. So this cannot be 8, it's 9, which makes that 8 there. Next to the black crop key dot, we have 1, 2, 3, 6, and 8 eliminated already. So then this has to be a 4, because 5, 7, and 9 can't be next to a black crop key dot. This can't be 7 or 9 here because of 7 and 9 in the box, so this is 5, which forces this to be a 7, 9 pair here. 4 is next to 2 or 8 on a black crop key dot. 9 eliminates 9 here, so this is 7, which makes this 9 to add up to 13. 7 eliminates 7 here. This is 6, which means it must add up to 10 with 4. That makes this 1 to add up to 5. 7 and 3 add up to 10. So this cannot be 3 here. It cannot be 3 in the rest of the row. This cannot be 6 and 3 to be in a 1 to 2 ratio because of the 3 in the row, so this can't be 6. So this is 2 or 4, which adds up with 3 and 5 to add up to 7. Or 5 and 3 specifically. 2 could only have an 8 here because 3 is in the row. 4 could have 1 or 6 here because you don't have anything else. This digit must be 4 or more away from 7 or 9, which is also 1 through 5. We can't have a 5 here because of 5 in the column, so this is 1 through 4. We can't have a 4 here because 4 in the box. We can't have a 3 here because of 3 in the row. So we cannot have 1 and 2 here because of that would eliminate all possibilities for that cell. Also, 1 and 2 can never be next to 3 on a Whisper 4 line, so this must be 5, which means this is 5 and 2 to add up to 7. which plus 9 is adding up to 16. 2 eliminates 2 in the rest of the row, so this is 5. This is 1, which can only have a 9 between them. Also, actually, we have a 7 already in the row. This cannot be 1. It cannot be 3. To add up to 5, it must add up to 10. So this is 2 and 8, and 2 is in a 1 to 2 ratio with 4, since it can't be with 1 here. And the remaining digit in the row is 6. So these W arrows are done. We have everything filled out except for here and here. So that means we have to do probably just the rest being Sudoku. 8 eliminates 8 here, so that's 2. Yep, we just have to do normal Sudoku now. Okay. So what are the areas which have the most information? We have row 7 can have the remaining digits of 3, 5, and 8, but 5 cannot be here because of 5 in the box, so 5 has to be here. This is then 3, 8 as a pair. This upper central box has 6 digits filled in. The rest are 3, 6, and 8. Okay, so this cannot be 8 here because of 8 in the column, so this is 3 or 6. Remaining digits in column 6 then are 3, 4, and 6. Okay. Now we have to do sets of 5. Row 6 has the remaining digits 2, 3, 4, 5. And this can't be 2 here. This cannot be 2 or 5 here because of 2 in the box or 2 and 5 in the column. No 3 or 4 here because of 3 or 4 in the column. No 5 here because of 5 in the column. This lower central box is 2, 3, 4, and 6, but 4 cannot be here, so this is 2, 3, 6, 2, 3, 6. Column 2, we have 2, 3, 5, and 8 remaining. Okay. And this digit cannot be 2, 3, or 5 because of 3 in the box and 2 and 5 in the row. That makes this an 8. So no 8 here, no 8 here, no 8 here. This can't be 3 because of 3 in the box. This can't be 2 because of 2 in the row, and this can't be 5 because of 5 in the box. The rest of this upper left-hand box is 1, 2, 4, 5. And obviously, this can't be 4, 2, or 5 because of 2, 4, 5 in the row. So this is a 1, which eliminates 1 in the rest of the box. This 8 eliminates 8 here. Excuse me. Remaining digits in row 3 are 3, 6, and 7. This can't be 7 because of 7 in the column, so 7 has to be here, which makes this a 3, 6 pair here. Where is 1 in column 3? Can't be here because of 3 in the box. Can't be here because of, can't be here because of 1 in the box. Same with this. And can't be here because of 1 in the row. This is filled out, so 1 has to be there. Okay. Remaining digits of this upper right-hand box are 1, 3, 6, and 9. This can't be 1 because of 1 in the column. This can't be 9 because of 9 in the column. Remaining digits in this left central box are 2 through... Oh, this 4 eliminates 4 in the rest of the box. So where is the 7 then in this box? it has to be here. Five eliminates 5 in the rest of the column. Rest of column 1, we have 2, 3, 4, and 9. Well, 4 cannot be here or here. So where's 4 in this upper left-hand box? It's there. This is then 2, 3, or 9. That means the remaining digits in column 3 have to be 7 and 8 because of the 2, 5 pair in the column. 8 eliminates 8 here, so this is 7, which makes this 8. We have 8 sevens. We know where the last 7 has to be. It has to be here. Okay, remaining digits of row 4 are 3, 5, 6, and 8. This cannot be 5 or 8 because of 5 or 8 in the column. This can't be 5 because of 5 in the column. We have a 3, 6, 8 triplet in column 8, which eliminates 3, 6, and 8 in the rest of the column. So this can't be 3 or 6, it's 9, which eliminates 9 in the rest of the box and column. That leaves this digit as a 4. 4 eliminates 4 here. Where is 4 in row 6? It can only be here now. So that's 4. Remaining digits of column 7 are 1, 3, and 6, but this cannot be 1 here, so this is 3 or 6 as a possibility, which means we have a 3, 6, 3, 6 pair in column 7, which means this can't be 3 or 6, it's 1. So there's no 1 here. Where is 8 possible then in this upper central box? It can only be here, so this is 8 there. We have a 3, 8 pair in this lower right-hand box, which eliminates 3 and 8 from the rest of the box. This can't be 3. That's 6, which makes this 3. That eliminates 3 here, so it's 5. No 5 here, it's 2, which means this can't be 2, it's 3. No 3 here again, so that's 5, which eliminates 5 here, so it's 2 and 5. 2 eliminates 2 here, so it's 3, which eliminates 3 in the rest of the box and row. This 4 eliminates 4 here, so that's 6, which makes this 2. 2 eliminates 2 here, so it's 9 and 2. This cannot be 2 or 6, so that's 3. This can't be 3 or 6, so it's 4. 3 eliminates 3 here, so it's 6. And 6 eliminates 6 here, so it's 3. That makes this 6 and 3. Which eliminates 3 here, so that's 8 and 3. This can't be 3 or 8, it's 6. This can't be 3, 5, or 6, it's 8. That leaves this as a 9 and this as a 1. Yeah, so that's how you go about it. Not too bad. I'm just debating whether I should consider it very easy or easy. The logic behind it isn't hard. The execution could be a little problematic, I guess, but maybe not that problematic. I'm not sure. Anyways, either way, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.